Hello and welcome back to the machine learning video series. Till now, we have covered all three categories of machine learning, and during this period, we mentioned a phrase called neural networks a couple of times. And believe me, no machine learning program is complete without discussing neural networks. Artificial neural networks are a very simplistic representation of how the human brain works. In our brain, there are billions of cells called neurons, which process information in the form of electrical signals. External information or stimuli is received by a neuron, processed in the neuron cell body, converted to an output, and passed to the next neuron. The next neuron can choose to either accept it or reject it depending on the strength of the signal. Similarly, a neural network consists of layers of neurons connected to each other across the layer. The first layer is called input layer, and the last layer is called the output layer. All other layers in between are called hidden layers. In artificial neural networks, every neuron connection has its own weight, which is multiplied to the input fed to the neuron. This weight denotes the strength of the connection. Every neuron has a bias that is added to the input supplied by the previous layer. These weights and biases are updated such that the final output in the last layer gives an accurate prediction. The output of n-1th layer is an input to nth layer. Activation function is applied to the output before feeding it to the next layer. Activation functions are functions that induce non-linearity in the output of a neuron. A neural network without an activation function is essentially just a linear regression model. Now, there is a term called backpropagation, which refers to the process by which a neural network learns from its mistakes while training. Neural network gives some output from a given set of inputs. Similar to linear or logistic regression, the error between the predicted value and the actual value is to be minimized. In backpropagation, the error between the predicted value and the actual value is differentiated with respect to the weights of the last layer and equated to 0. Hence, the weights of the last layer of the network are updated. Gradient descent or modification of gradient descent is applied to change the weights and biases. The weights and biases are updated starting from the last layer to the first layer. So the forward pass is the calculation process where an input is given to the neural network and an output is received. A loss value is calculated from the output and the actual labels. And then backward pass is done where the model counts the changes in weights using gradient descent algorithm. Backward and forward pass together make one iteration. The government uses neural network powered systems on many national highways to monitor traffic. Modern systems can detect cars and can even read their license plates. Neural networks are also widely used in document classification. By classifying text, we are aiming to assign one or more classes or categories to a document, making it easier to manage and sort. Hence, any document can be classified according to its contents. Through the use of machine learning, Accenture was able to analyze case files and interview transcripts to identify specific attributes associated with high-risk groups. A solution was then implemented to monitor for suspicious transactions using these criteria. Similarly, artificial intelligence and machine learning have been helpful in many areas throughout the world and is continuing to expand to more and more areas. In the next video, we will see what good and bad things AI have been up to. See you there. Thank you.